All right, folks, Chapter 18, PowerPoint, Slide 9, question number 4. 0.425 grams of sodium hydroxide is dissolved in 2 liters of solution, where we have the concentration of dihydrogen phosphate and hydrogen phosphate both equal to 0.1 molar. What's the pH before and after adding the sodium hydroxide? It looks like we got a buffer problem here. Let's write the buffer equation. The pH is going to be the pKa plus the log of the base, which is this, over the acid concentration. So I recognize this as a conjugate acid-base pair because they differ by the presence of a single proton. Well, in this case, they're equal. So I've got the log of 1, which is 0. So before adding any sodium hydroxide, the pH is just going to be the pKa. Well, what is the pKa of this acid? Well, let's look it up here. Table 17.3 in my text. Let's see. Dihydrogen phosphate has a Ka of 6.2 times 10 to the negative 8. Let's see, my Ka is 6.2 times 10 to the negative 8. So my pKa is going to be the negative log of 6.2 times 10 to the negative 8. So the pKa will be about 8. Let's see what it is exactly. 6.2 times 10 to the power of 8. Let's make it negative. There it is over there. We got to take the log of that. Negative 7.2. Well, it's 7.2, so 7.21. That's it. That's going to be the pH prior to adding any acid or base. Now we're going to add some sodium hydroxide, so the pH is going to go up. The pH better be bigger than this when we're done. How high is it going to go up? Well, let's find out. Let's see. What's the base going to react with? Is it going to react with this or this? What's going to react with the acid? It'll react with the acid form, preferentially. So we're going to have hydrogen phosphate ion. That's going to react with, I don't have to worry about sodium. It's going to react with hydroxide. And it's going to react irreversibly. Let's see, this is going to be the base, so this is going to go this way. A proton's going to go this way. And I'm going to form the hydrogen phosphate ion and water. We got to figure out how much of this reacts. Well, let's find out. I'm going to find out how many moles of dihydrogen phosphate I have. Let's see. 0.1 molar. So I got 0.1 moles of dihydrogen phosphate per liter. That's what that capital M means, molarity, times a total of 2 liters. Oh, that's 2 liters. So that's 0.2 moles of dihydrogen phosphate that I've got present. How much sodium hydroxide do I have present? 0.425 grams of sodium hydroxide. That's what I'm going to add. And if you do the math, I think that's 40 grams per mole. 23, 16, and 1. Yeah. That's 40 grams of sodium hydroxide and 1 mole of sodium hydroxide. Wonder which is going to be in excess. Let's find out. 0.425 divided by 40. 0.0106 moles of hydroxide. So it looks like this is in excess. We're going to produce, let's see, 0.2 moles of this will react, 0.0106 moles will react with 0.0106 moles of this. So 0.2 minus 0.0106 means I will have 0.1894 moles of hydrogen dihydrogen phosphate left over. So notice I start with 0.2 moles of this stuff. It's going to react with 0.0106 moles of the hydroxide. All of this reacts, and it's going to produce an additional 0.0106 moles of the hydrogen phosphate, and this will drop to this amount. So in addition to figuring out how much of this reacted, we have to figure out, which we did, how much of this is produced, and add it to the amount of hydrogen phosphate that's present. Well, let's figure that out. It's going to be the same calculation that we just did here, right? I mean, we've got 0.1 moles of hydrogen phosphate per liter, and we've got 2 liters of it. So it'll be the same calculation. It's going to be 0.2 moles of the stuff that we start with. All right, this is getting a little crowded here, so let me just try to recap. I figured out that we started with 0.2 moles of dihydrogen phosphate. This reacted with 0.0106 moles of hydroxide, and that would produce 0.0106 moles of hydrogen phosphate, of course in water. So we lost 0.0106 moles of this stuff. Dihydrogen phosphate means we have 0.1894 moles of dihydrogen phosphate left over. This is my acid form. Pen's running out of ink. Let's use this one. All of this reacted. Now I have, because my concentration of the acid and the conjugate base are both 0.1 molar, and they're both in 2 liters of solution, I'll start with 0.2 moles of hydrogen phosphate. It'll also be 0.2 moles, of dihydrogen phosphate. It'll also be 0.2 moles of dihydrogen phosphate that I start with. So for my hydrogen phosphate, I have 0.2 moles of the stuff to start with, but I will be adding 0.0106 moles that was produced in this reaction when I added the hydroxide. 0.2 plus 0.0106, that's a total of 0.2106 moles of the hydrogen phosphate. So I got my amount of dihydrogen phosphate, my conjugate acid. I now have my amount of hydrogen phosphate, my conjugate base, and now I can use, finally, my buffer equation. The pH is the pKa, which you might remember last time. We calculated as 7.21 right over here. So my pH is my pKa, 7.21, plus the log of the base concentration, there's my base, divided by my acid concentration. Wait, Dr. K, you say, why didn't you divide by the volume if we're doing concentrations here? Well, I can. I mean, I divide this by 2 liters and I divide this by 2 liters, but notice those cancel out. Remember, that always happens when you're in a buffer, because both substances are in the same volume. So I think we got it. 0.2106. Let's divide that by 0.1894. Yep, let's take the log of that, and then we're going to add that to 7.21, and we get 7.26 as our answer. And we're done with that particular problem.